Douglas here from WeakNet Labs. In this video demonstration, I'm going to be walking you through exercise 9 of the second Capture the Flag challenge offered by InfoSecInstitute.com. Now the URL for this is ctf.infosecinstitute.com/ctf2, and you can access the levels in this levels menu in the top left-hand side. Just click on it, go down to level 9, and if you do so, you're presented with this simple static web page right here. And the static web page says that we are automatically logged in as John Doe. Automatically logged in. And we need to find a way to be logged in as the user Mary Jane in order to see her profile, I guess, instead of John Doe's. And this is John Doe's profile here. So first things first, let's right-click, go to Inspect Element, and we're actually going to refresh the page, and we're going to watch the network traffic and see if there are any 302s or redirects to see if there is another PHP file handling the login, the authentication, or if it's actually ex9.php handling the authentication. So just go ahead and click refresh after clicking the little network tab here. And yes, there are no 302 status codes here, so most likely is ex9.php is handling this. So what we're going to do is click on this file name here, and we can browse through the headers here, and we can see cookies and things like that. There's cookie here, and looks like there is a user cookie here. So let's pull this value out here. What I'm going to do is I'm just actually going to click on the edit this cookie extension, which is a really cool extension. And look at that, it actually just shows it for me. It skips over the PHP session ID, which is created from the PHP function to start the session. So I'm going to copy this value here. This value looks very peculiar in the fact that it is not hexadecimal. It doesn't say John Doe, obviously. It doesn't say John Doe at all. And so, but part of it is hexadecimal. This right here is an equal symbol in HTTP protocol encoding. And the reason why it's encoded like that is most likely for the transport of the HTTP protocol for the headers. So this to me now looks like a base 64. So I actually have an extension installed in Weaker-than Linux 6 to encode and decode base 64. So let's paste that right in. And it did in fact change the %3D, as you see, into an equal symbol, because if you try to decode a % symbol in a 3D, you'll most likely get an error. So let's base decode this, and yes, look, we do have John plus Doe. So let's do Mary plus Jane, and we're going to encode this value, and then we're going to copy this value, and we're actually going to set this with the same cookie editor here. This extension is absolutely spectacular. I've used a lot of other cookie extensions in the past, and as a web developer, I know that a lot of them actually do not work. And some of them look flashy, and they organize the cookies well for reading, but they don't set the cookies properly, and they just simply don't work. I would definitely recommend using this edit this cookie extension. So now that the cookie is set, as we see here, if we click on it, we'll see that our new cookie as the base 64 encoded string right here, Mary Jane, is set. Let's refresh the page and hope this works. Cross your fingers. Yes, okay, so we have successfully completed exercise 9 of the second CTF challenge offered by InfoSec Institute. If you have any questions about any of these videos, you could email me. I'm weaknetlabs@gmail.com, or simply leave a comment in the thread for the video. Thank you.